If it is giving a rotating vector, your sine standard, your waveform is output is similar to sine standard. So for that purpose, whatever it says here, these are not poles. A, B, C are poles. VA naught, VB naught, VC naught is all pole voltage. To get a rotating vector, what is the requirement? VA naught plus VB naught e to the power of j2 pi by 3 plus VC naught e to the power of minus j2 pi by 3 means that is nothing but a rotating vector. So in that way we have to get the voltages. So for that what we are using here. For example, if the upper switch is connected, what is VA naught? This is connected to VDC so that your voltage will become VDC. If the lower switch is turned on, A is connected to O so that this voltage will become 0. So in each leg there are two switches are there, three legs are there. If the upper switch is turned on, that pole voltage is VDC. The lower switch is turned on, pole voltage will become 0. Right? So that here you see here, this is the what is that definition of space vector. What is the space vector? VA naught plus VB naught e to the power of j2 by 3 plus VC naught e to the power of minus j2 by 3 j4 by 3. So here VA naught, B naught, C naught are called pole voltages. Here there is a common mode voltage VA naught plus VB naught plus VC naught by 3 is nothing but a common mode voltage. So this is a definition of space vector with three pole voltages. It should be rotated in nature. That's why we are giving the definition like this. For example, in the top switch, there are switching states. I told you switching states. So every time in this vector, either top or bottom should be turned on. For example, top, bottom, bottom. Or otherwise bottom, top, bottom. Or all tops, all bottoms. Like that, there are 2 to the power of 3 switching states are possible here. Because 3 legs are there to devise either first or second one. That's why it is 2 to the power of 3 switching states are possible. Totally 8 switching states are possible. What are the switching states? We will see that. So for example, this is top is closed, bottom, bottom. So how do we recognize that switching states? So for that purpose, if the top is turned on 1, if the bottom is turned on 0. For example, in the first state, 1, 0, 0, that is the switching state. Plus, minus, minus. Top is plus, bottom is minus. What is the switching state when top, bottom, bottom is turned on? Plus, minus, minus. In that similar way here, plus, plus, minus. Top, top, bottom. Here also, bottom, top, bottom. That is minus, plus, minus. Bottom, minus, plus, minus. This is one switching state. Similarly, here also, minus, plus, plus. That is switching state 4. In a similar manner, there are 2 to the power of switching states are there. One is, what is minus, minus, plus means? Minus, minus, plus means bottom, bottom, top. First leg bottom switch, second leg bottom switch, third leg top switch. Either any combinations. Very common. What is the sequence we have to follow is important. And one more thing is how much time you have to turn on the switching state is important. That will decide your rotating vector. Okay. So that what happens here, for example here, all negative means minus, 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 all bottom. Here all top. So that what is the top? What is VA naught here in this case? Top is turned on. What is VA naught? The top is turned on. What is VA naught? VDC. You see, top switch is turned on. What is the pole voltage? A is connected here. So that what is the voltage across this? That is nothing but VDC. Here also VDC. Here also VDC. What is the reference? What is your voltage vector? VDC plus VDC e power j2 pi by 3 plus VDC e power minus j2 pi by 3 are formula. So the resultant will become 0. For example, plus minus minus. What is the reference? Plus means top, bottom, bottom. What is VA naught? VDC. What is VB naught? VC naught. What is the reference? VDC. VDC plus rest of the things are 0. Rest of the things are 0. For example, minus plus minus. Minus plus minus. VA naught is 0. VB naught. VDC, VC naught. What is the reference? 0 plus VDC e power j2 pi by 3 plus 0. What is that? VDC at an angle of 120. So your reference vector is at VDC at an angle of 120 you are going to get. Like that when we are operating some all plus or minus 0. When plus minus minus we are going to get VDC at an angle of 120 like that. Plus minus minus is VDC at an angle of 0. Minus plus minus means VDC at an angle of 120. Minus minus plus means 0 plus VDC e power minus 2 by that means at an angle of minus 2 or 2 or minus 1. Like that we make our vector to rotate by jump for every 6 degrees. You see here, for example, here state 2 plus minus. What is VA naught? VDC. VB naught is VDC. VC naught is 0. So that VA naught plus VDC e power j2 pi by 3 plus 0. If you simplify that, we are going to get VDC at an angle of 60 degrees. Means if you maintain a switching state plus minus upper lower, what is the reference vector we are going to get? That is VDC at an angle of 60 degrees. Like minus plus minus 120. Clear? So like that we are going to get various switching states. You see it. What is the switching state plus minus? What is the reference voltage? VDC at an angle of 0. If you go for plus minus, VDC at an angle of 60. Minus plus minus, VDC at an angle of 120. Minus plus VDC at an angle of 180. Minus plus means minus 240. Minus plus minus, like that is 300. So if you operate these switching states in this sequence, first I am giving for plus minus top bottom, like that we are going for bottom top bottom. Like that if you operate them, you are going to get the resultant vector from VA naught, VB naught, VC naught, and it is jumping for every 6 degrees. Is it satisfying our three-phase AC supply? Yes. So if you are operating your switches in this manner for some time period, so obviously you are going to get a rotating vector. That is nothing but your inverter is fulfilling a three-phase AC supply effect. Okay? But what space vector configuration technique says, you don't jump for 60 degrees. You jump for 30 degrees. And also 30. How many times it is improved? For example, if you go for 15, 3 times, 15, like that it will improve. And also we have to control the magnitude of this V reference also. Means what is the magnitude of this V reference? For example, this is the V reference. I don't want VDC. I want only 75%. So that here I am going to get VDC. VDC, 75% of this one I am going to get. 50% also I can control. 25% also I can control. 80% also I can control. 86.6% also I can control. What is the maximum voltage you tell me? Maximum VDC, maximum value, you have a vector inscribed in the circuit, hexagon. What's the maximum? I want to have 0.9, 90 times of VDC. 90 times of VDC means here 90 times. Here it is entering away from the hexagon. That is not overcompletion. It is entering here, again it is coming here. But this thing is, it should be inscribed in hexagon. And also the magnitude also, I want only 70% of it. Some application want 60%. Some application means what is the requirement here? We should control this magnitude also. I am controlling this magnitude here, this much, so that your vector is rotated like this. I want to make it 50%, your vector will rotate in this way. 25%, your vector will rotate in this way. So that controlling is also how it is possible. Only jumping, okay. It is jumping for every 60 degrees, okay, plus minus in that sequence, if I go for that, okay, it is going. But my intention is I have to control the output voltage also, how it is possible by using this. For that, we have to synthesize this vector. We have to synthesize this space vector. Synthesize this space vector means, for example, you see here, I want to get an angle of alpha, and this magnitude is 70% of it. That is my requirement. So what I do? For example, I want to have a vector with 30 degrees. I want to have a vector with 30 degrees, and its magnitude is 80%. Is it possible? Is it possible? Because we have only 61, but we can make it possible by turning on these switches in a different time periods. That is the synthesis of space vector. What is the requirement and how to achieve that? That is a requirement. So here you see, the reference vector, V reference is situated in sector 1, and alpha represents the position of the reference vector with respect to the beginning of the sector. And also assume that the sampling period Ts is divided into 3 intervals T1, T2, T0 so as to produce a vector T1 for T1 seconds and T2 for T2 seconds and 0 state for T0 seconds. T1, T2, T0 calculated based on volt second balance. How it is possible we have to see. For example, I want to have a vector with an angle of alpha. Actually, what is the requirement here? This one, this will just like this. But I want to have a vector here which has to make an angle of alpha. How it is possible? So for that we are going for. So this is T1 time period, this is T2 time period, this is T0 time period. We are operating in a different time periods of this switching state plus minus minus, plus plus minus, and also all plus or all minus we have to operate such that we have to have a reference vector at an angle of alpha. For example, your reference vector is V reference is a magnitude and it is making it an angle of alpha. So how do you resolve that volt time balance equation? Vd is for T1, Vd is for T1 plus V2 cos 60. We are resolving cos vector, all possible vectors are resolving cos vector and vector. So what happens here? If this is V1, state plus minus minus is maintained for 1 microsecond. T1 is 1 microsecond, for example. So into T1, and this V2 if you resolve cos generally, V2 cos 60. That is V2 is nothing but Vd into such a time period of T2. That is equal to V reference we are resolving now. V reference into cos alpha for a period of Ts. Ts is nothing but switching time period. That we are going to decide. I'm not factoring it depends, we will see now. Okay. So Ts is this. And also similarly sin 60. What is the sin 60 of this one? 0. Vertical combination. What is the vertical of this V2? Sin 60 for a period of T2. And also what is this one? V reference into sin 60 for a period of Ts. So this is volt time balance. Voltage and time balance. We have two equations. If we simplify the equations, we are going to get T1 should be Yates modulation index. In this one, only this T1, T2, this T2 we are substituting here. The second equation we are substituting for T2. And if we resolve that, if we simplify that, we are going to get T1 is nothing but A into switching time period into sin pi by 3 minus alpha by sin pi by 3. That is T1 time period. And what is T2? A Ts into sin alpha by sin pi by 3. So what is switching time is how many samples you are going to derive from this we are going to find. Here what happens here T1, T2. What is this meaning? What's the meaning of that? And T0 is nothing but total switching time period minus of T1 and T2 so that we have T0. What's the meaning of this one? You want to have a reference vector at an angle of alpha 1. You have to turn on this switching state plus minus 1 for this much time period. A into A is modulation index, A reference by V. And how much you want to 90% or 50% or 60% gives. For example, 80%, 0.8. Ts, your switching time, you decide some value, some seconds you decide. Sin of pi by 3 minus alpha. Alpha is nothing but here, for example, 30 degrees, alpha means you have to take 30 degrees. And if you find out T1, you are going to get as, for example, 45 milliseconds. And T2 is also you are going to get as 45 milliseconds. And T0 is for some time period. What this indicates is, for example, you are having one force in this direction. One objectal force is acting in this way. You have an object, one force is acting in this way, the other force is acting with 60 degrees. Other force is acting with 60 degrees. What is the path of this object? Both are same. This is 60 degrees. One force is horizontal, other force is 60 degrees. You connected to an object and you are applying both the forces in this direction. Both are with same magnitude. In which path it will move? Right? How many degrees? 30 degrees. It will move in 30 degrees. But you want, it is moving like continuously. But you want to cut it for 90% or 80%. What do you have to do? You have to move this one only 1 centimeter. 5 Newton meter, 5 Newton meter is acting on the body. You have to move it for only 1 centimeter. What is the requirement? When both are equal, it will move with But you want to stop it for 1 centimeter. How is it possible? What do you have to do? Yes? When two forces are acting, how can we limit this one to travel 1 centimeter only?
Sorry, force type we have to.
Time restricted, no problem. It will go in this way or this way. You are one way that voltage into time is nothing but force here. You want to move this one only 1 centimeter. What's the other requirement? What is the other requirement? Force continuous in about the both forces are acting. It is moving like this. But you have to restrict for 1 centimeter or 1 meter. Yes. Yes, one more force is required. Definitely, one more force is required. So based on these three forces balancing time periods, it will move for 1 centimeter. Then we are doing. What we are doing, these forces are but we are maintaining plus minus minus for T1 seconds. Plus minus for T2 seconds. If both T1 and T2 are both are same, the switching state, this is for 5 milliseconds, this is for 5 milliseconds, your reference vector is a manual activities. But how can you make 80%? You have to apply the third one. That third force is nothing but this sector. R plus R minus. R plus and R minus. So that we calculated. How much time you have to maintain plus minus minus, how much time you have to maintain plus minus, and how much time you have to maintain either R plus or R minus. Based on this time balance only, you are going to synthesize a vector at an angle of R. For example, R equal to 30, we have substituted. This is for 5 milliseconds, 5 milliseconds, 2 milliseconds. So that you are going to get this difference is 90% or 1 meter or 1 centimeter. Right? That is the logic behind it. For example, you want to 30 to 45 degrees. What change you are going to take? You want to take it, it is 30 degrees for example. You want to have the same reference with 45. This time period is more than this time period, then it will move in this. Right? The opposite direction time period may be such that it will have to only same reference value. In that way, we have to decide this how much time period. So that 45 degrees if you mentioned here, we are going to get T1, T2, T3. Definitely, this T2 will dominate this one, so that it will move towards this. If T1 dominates this one, it will move towards this. Based on this magnitude or time period, this vector will be either this much or this much or this much. That is the logic behind the application of that. What is the meaning here? How much time you are operating the various switching states will decide the position of the reference vector. But your intention is I want to place my reference vector for 15, 15, 15, 15 in this sequence I want to do it. How it is possible? That's the logic behind it. Okay? Clear? You got the point? Only thing is how much magnitude and what is the angle. That should be completed in one revolution, for example. For example, your fundamental frequency is 50 Hz. It is operating for 60, every 60. What is the frequency of your vector? In one cycle, 50 Hz, but your sector, your reference vector is making for 6 jumps in one revolution. What is the frequency of your reference vector? 6 into 50. 6 into 50. For example, every 50 degrees it is moving. What is it? 50 Hz is the fundamental frequency. What is your switching frequency? Every 15 it is moving. 360 divided by 50 means 360 by 15. 22. 22 or 24? 24. What is your switching frequency? 24 into 50. So that is not TS. And where to jump your vector you have to decide. Based on that 1 by that frequency is nothing but the time period TS. In that way you will decide what is. And first you have to find out whether it has jump for 60 or 30 or 40. For example, there are 48 samples. This is called sample. First sample, second sample, third. 48 samples are there. What is the switching frequency? 2.4 kHz. 48 into 50. So that 2.4 kHz we are getting. So that your switching frequency, if your switching frequency is 2.4 kHz, what is your switching time? 1 by 2.4 kHz. That is your ES. And also you want to get 75%. What is your gain? 0.75. You want to get only not complete weight is only 75% only I want. You are controlling the voltage. 75% is 0.75. 0.75 1 by 2.5 kHz into sine 5 by 3. You want to get a sample at, for example, fifth sample. Fifth sample is 48, 7.5 into 5. How many degrees you are going to get? That degrees you have to substitute. You will come to know which state you have to operate for how much time. To get a vector with, for example, 60 degrees or 120 degrees or less than 120 degrees like that. In that way, we have to calculate the switching time period. That is the logic behind this one. You see here, these are the switching sequence A, B, C. And also one more thing, this is maintained for all minus. And all minus means all bottom. After that, we have to maintain for plus minus for T1 time period. Right? Next sector, plus minus for T2. And after that, T0 by 2 is all plus. Okay, how do you operate this one is, here plus minus. After that, you have to remember, sequence should be only one change. All plus. Plus minus, all plus. Only one switch should be disturbed. First is I am taking plus minus. I should not take all plus. Next week. Only one should be changed. Either bottom or top or first leg or second leg, third leg. Only one switch should be changed. So like that. What is the sequence here? These are number of samples are given by numbers. 8 means all minus. 1 means plus minus. Like that I have to do. What is the sequence here? 8, 1, 2, 7 means all negative. Only 1 negative. Only 2 negative. All positive. After the next sample, you have to go for in a reverse way. At that particular moment, what is that? All top is on. Then, if you go for all bottom, there is a disturbance. So, what's the sequence? Only one switch you have to do. So, that's why what happens here? All plus 2, plus minus, all minus. So, in that way, this is called positive sequence and negative sequence. In that way, we have to operate these switches. You see that, sector 1, for example. What is the R sequence? All minus, plus minus, and all plus. Like that. This is 8127 is R sequence, 7218 is half sequence. Just what I do. In that similar way, in the all sector, second sector, third sector, fourth sector, this switching sequence we have to follow. One is on and second is. You are entering into a room. You are turning on light, and you have to. While coming, off, like that you have to come. Reverse. So what are the steps here? So how do you proceed the algorithm? You want to implement in DSP controllers or FPGA controllers here. Find the sector in which variables is located. Means I want to get a sample in the second sector. Second is for 60 to 120. So the sample is in which sector you have to identify first of all. And from that instant phases you have to develop the reference. And after that alpha equal to theta minus k into 60. Every 60 degrees you have to subtract k is such that 1 plus 1 plus 1 plus 1 you have to add for first sector, second sector, and third sector. And you have to find out compute T1 and T2 and determine the switching pattern. This is the steps to implement XUV diagram. This is not 3-level inverter. We are seeing 2-level inverter. Now it is a 3-level inverter. What is meant by 3-level inverter? In each switch, instead of 1, each leg 2 plus 2, 2 plus 2, 2 plus 2 we have. This is called 3-level inverter. Okay. For example, you have 4-level inverter. How many switches are there? 5-level inverter. Here 4 unali, here 4. 4 and 4. 7-level inverter. 6 top, 6 bottom. 6 top, 6 bottom. Like that. It is called 3-level inverter. 3-level inverter. You are going to get the inverter output voltage at 3 levels. When the levels are increasing, it is like a steps, so that it is approaching towards the sanction. That is the purpose of 3-level inverter. You see here. What is the switching timings here? So here A, B, C are the pole voltages. And in the previous case, only either plus and minus is there. Either top or bottom. That's why first switching state, how do you represent it? Plus, minus. But in this case, the combination we are going to have 4 switches are there in each ring. Either top to, or middle to, or bottom to. What are the switching states? How many switching states we are going to get? And in each leg of 3 combinations, there are 3 ways. In the previous case, each leg there are 2 combinations, 3 ways. How many switching states? 2 to 4 of them. Here, either top to, or middle to, or bottom to. 3 legs. How many switching states? 3 over 3. 27 switching states are there. Combinations are 27. But only 8 got either plus or minus for this, what is the requirement? To identify your controller, it requires some name, it requires some reference. That reference we are going to have in terms of PON. The previous case plus minus, but here PON. P means top two, O means middle two, N means bottom two. For example, here switching condition is on, off. For example, P. What is P? S11, S2 on, and these two are on. Okay? When these two are on, what is a pole voltage? You tell me. This is VDC. Here VDC by 2, VDC by 2. When these two are turned on, this point B is connected to A. What is the voltage here? VN, VDC by 2. And top two are on, it is VDC by 2. When middle two are on, this is up, this is up. What is the voltage? What is the voltage? Where it is connected? 4, so that it is here. When bottom two are turned on, so it is connected this way. So what is the pole voltage? Minus VDC. The previous case I have VDC are 0. But in this case there are 3 combinations are there. There is VDC by 2, 0, minus VDC by 2. Okay? For example, top. This top. What is your voltage? Reference voltage? VDC by 2 plus VDC by 2 e power j2 pi by 3 plus VDC by 2 e power minus j2. What is the voltage? What is the voltage? 0. That is 0. For example, all middle are turned on. What is the voltage? 0. Like that, there are 2 to the power of 3 switching states are there. 27 switching states are 3 power 3. 27 switching states are possible. That switching states, if we keep on a space vector diagram, so how will you see? This is line to line voltage. Like this, we are going to get a line to line voltage here in case of 3W inverter. But how these switching states are, like this, we are going to get. Exactly close to it. What is POO? POO means top two, middle two, middle two. What is the reference? Plus VDC by 2 plus 0 plus 0. So that plus VDC by 2 at an angle of 0. So what is the vector here? POO is this one. So you are going to get have a vector with VDC by 2 for this. For example, PNN, top, bottom. So what is the reference? VDC by 2 minus VDC by 2 e power j2 by 3 minus VDC by 2 e power minus j2. That will gives you VDC at an angle of 0. So that vector is nothing but PNN, VDC at an angle of 0. PPO. PPO means top to middle. Top to means VDC plus VDC means that is similar to plus minus. But magnitude is only VDC by 2, so that we are going to get this way. Like this, all combinations, 27 combinations, if you apply on a reference vector, if you plot them like a space vector diagram, you are going to get a hexagon. This is one hexagon, this is one hexagon, like that we are going to get. But here the question is, for the 3-level inverter, how do you synthesize the reference? The previous case what I had done at the T1, T2, T0. How much time T0 for alpha equal to 50 degrees, T1. That much time period we operated the switches so that we are able to get a vector with 50 degrees with 80%. But here what is the requirement? I want to go to 75%. Which vector I have to operate? Means, for example, 50 degrees means 7.5 degrees means this is the vector. Right? Where that vector, for example, you want to get 7.5 degrees and 80%. Means what is the location? 7.5 degrees is here. 80% means your vector is here. Your tip of the vector is here. To get a tip of the vector here with a 7.5 degrees, what are the switching states you have to operate? You have to operate these switching states. And for them, we have to calculate what is the time period. Either the same one, we have PNN, PON, PO. How much time period we have to operate? That we have to calculate. That's why complexity is more. Here, every vector we have to find out what is the 7.5. What is the magnitude 80%? Which states are connected with that? How much time we have to operate with that? Then only you are going to get a vector with 7.5 degrees. It will go in the outer vector. It goes in the the outer perimeter. That is nothing but 3-level inverter synthesis of space vector. For example, it is less than 50%, whatever it is. Less than 50 means here. 1, 2, 3, 4, 5, 6, 7 are there. Out of 7, we have to choose which one should be operated, either PO or ONN. Which one should be operated, that we have to decide. And outside will goes in this way means that is equal to 2-level inverter output. When your vector is moving in the outer spectrally, that will use the 3-level inverter output. So what is it you see here? For example, a vector is at an angle of theta, this is the vector position. So what are the switching states connected with this? These are the switching states. But each and every switching state can be calculated as the If you go for simple 2-level inverter, volt time balance it cannot work out. That's why what's the other things we have to go for. So that this is given in long band, retrace it is given in manual paper. For a 3-level inverter, V1, T, V1, TA, V3, TV, V4, like that, based on this V1, V2, V4, we operated that. These are the values given by someone, mathematical calculation by mathematical calculators. We are using these values as so when TA is operated for this, A is operated for an angle of theta, how much time we have to operate, we will decide. This one, like that we have to operate. And the next sample, for example, here. So when I go to reverse direction. After 60 degrees, it will enter here. It will enter here, this vector. Again, these are the connectivity. After that, sometime it will enter this. So we have to find out what is the location of your rotating vector and what are the switching time periods connected with that. How much time you have to operate each one to get a smooth vector. Where is your implementation of this vector? Okay. So if you implement, if you follow that, you see here, these are vectors. 1, 2, 3, 4, 5, 6, 7, 8, like that, we are going to have 48 samples here. So your switching frequency is 48 into 50. So like that, this is the switching pattern. One is one sample is clockwise, the second sample is anti-clockwise, clockwise, anti-clockwise, like that we have to implement that. So they are each and every switching state is given by some number. 1, 2, 3, 4, 5, 6, 7, 8, like that, 26, 27, 16, like that is given. So because our control has to recognize, so that's why each and every switching state is designated with some number. So based on that number, these are the 1.2 section. For example, there are 3 samples. First sample means what is switching states? 15, 17, 16, 4 you are counted. Whatever is 15, 16, they are the switching states. And for the second sample, from ONN you have to start. You see here, POO. After that, again, only one change. After that, this O is replaced by A, only one change. After that, this P is replaced by O. Only one switching state is system. So that we are going to have first 2, 3 samples. After that, in sector 4, only one sample is existing based on the hexagon. And after that, in sector 4, there are 4 samples are coming. Means how they are coming here, you see like this. 1, 2, 3, 4, 5, 6, 7, like that. In somewhere you are going to have 3, somewhere only 2, only 1, somewhere you are having 3. Like that it will change. We have nature of hexagon. So like this is inverter induction is also model. And the results you see, this is the line to line voltage of 3 level. You see. These pulses like that, this is only because of rotation of the vector. So this is 3 level line to line voltage. When a induction motor is connected on the speed and flux of with a load of 500 meter, we implemented on that. So that this is 2-level inverter. But the 2-level inverter, we got PH as 54.0, more than 50% is disturbance. Coming for 3-level inverter, it is coming for 28%. So what we discussed, this is only conventional distributor, basic it is. It's a very basic. Based on this basic concept, for the higher levels we are going, we are implementing. So for that, how do we calculate this time periods? For 3 levels, somebody has done some mathematical calculation and they got time periods. But if you go for 7 level or 99 level, I implemented 99 level. 99 level, how it is possible to find out the different these things, time periods? And controller is also, we have to recognize what's the sequence. For that case, we developed the different algorithms to simplify that. Higher level, as we said, higher level, we are going to simplify like a 2-level inverter, then we operated that. Okay, in that way we have done. You see here, this is 54.2 and this is 28.6. And TAG as well, modulation index 70%, 75%, 80%, 86%. As modulation index is increasing, the TAG will be there. For this case, we got 26.5. Okay. So what is the time? How much time is it? Fundamentals of business. Okay. Just this is the conclusion like this. Next one is what it is. There is only basic. This is we proposed a fraction approach. And at higher levels, how do we minimize it? How do we implement all the DSP controls? The first that we had done algorithm for multi-level equator fraction. What is the fraction approach? Means we see here. This is two-level equator. In this two-level equator, if I include a triangle in each and every triangle, what's the level of the equator? I included a triangle here. Then the space vector will become as 3 level. 300 2 triangles in there. 400 3 triangles in there. 500 4 triangles in there. So that I got this one as if I include a triangle here, this is 3. In each and every triangle I included a triangle. What is the level? 1, 2, 3, 4. You see here 1, 2, 3, 4. What is the level? 5. Again in this each triangle I included a triangle. If I 1, 2, 3, 4 does 8 out. 8 and 9 level. But computer triangle. 2 level only 1 triangle. 3 level only 2 triangles. If I include one more triangle in each and every triangle here, that is will become say 1, 2, 3, 4, 5, 6, 7, 8 means 9 level. Again if I include a triangle like that, it is increasing. It is fractal approach. Fractal is repetition. So this high level equator configuration I made into the 2 level and I implemented. That is my logic. Clear? So further what we are doing here, like this we are going to get a 5 level equator space vector. You say this is the 5 level. How many switches are top? 1, 2, 3, 4, 1, 2, 3, 4. How can you operate all 4? Second, third, fourth, fifth. Third, fourth, fifth, sixth. Like that, 4, 5, 6, 7. 5, 6, 7, 8. Like that we can operate. How many switching states we have? In each leg there are 4. Either first 4, second 4, third 4, like that we have. Okay. So how can you indicate that either this top 4 is on, I am indicating with P. Because I am given address bar, post address. To implement that. If top 4 is on, I can represent with P2. Next 4 is on, I represent with P1. Middle 4 is on, I represent with 0. O. And top but 1 and all bottom. So when all top are on, what's the voltage here? 1, 2, 3, 4. This is A. A is connected to here. So that what's the voltage? VDC by VDC plus VDC. I am taking 4 times of E. If I take E, each one will become VDC by 4. So that here E plus E, that is nothing but 2E. Only this one is off. 1, 2, 3, 4 are on. Then we are going to get E. All middle means you see here. This is the part to connect A. So that we are going to get 0. All this one, 1, 2, 3, 4, 1, 2, 3, 4. We are going to get minus E and last bottom 4 we are going to get minus E. So these are the voltage I am getting by using the 5 level inverter. There are 5 configurations are there, 5 states are there. 2 level only either plus minus. 3 level PON. But 5 level again 5. That 5, how can you write that 5? We are giving a number P2 is something, all top, P1 is something, O is something, N1 is something, X is all bottom. So that all top, bottom. What's the voltage? All top means 2E. All bottoms are, all middle means 0, 0. So that what is the voltage? 2E at an angle of 0. In that way, all voltages and all vectors, all switching states, if we keep in the form of the diagram like this way. So this will use P2, A2 means now 4. Last 4 will gives you 1, 2, 3, 4 types of E. Like this way I will get. Like that, this is the space vector diagram for 5 level inverter. And for that, this is a procedure how we implement this algorithm. And here I implemented one triangular. This is new novel algorithm which is about triangulation algorithm. Triangulation algorithm, mathematical approach we followed for this. You see this is right? So this is 2 level. If you include this, this is 3 level. I make this one as VDC 0. This is as VDC by. If this is VDC, what is this magnitude? VDC, but what is the angle? Angle is different, 60 degrees. Like that, I have taken some angles and also to find out this one, I made what is that? Average of this. Like that, a special sequence I implemented and I found in a very simple way this switching states. I have done the centroid of this triangle and this is a little bit discussion is line this. Okay, this is some different type of the. This is 4 types of E. 0 0, 4 4 0, R 0, 0 4 0. Like that, I have given the numbers here. If your location is here, first of all, you have to identify this time. So this coordinate are 4 0 0. This is 4 4 0. What is this coordinates of this one? 4 2 0. Average of this. 4 plus 4 by 2, 4 plus 0 by 2, 0 plus 0 by 2. 4 2 0 is the coordinate of this one. In the similar way, I censored this coordinate and that I implemented. So like this is triangulation. For example, this is 4 0 0 and all these are R zeros, R1s, R2s, R3s, R4s will give 0 and this is 4 4 0. This I want to have the what is the switching state 4 plus 4 by 2, that is 4, 4 plus 0 by 2, 4 2 0 and these are midpoints. In that sense I got this these things and also this is 4 0. Then what are the coordinates of this one? X is 2, Y is 2 root 3. 2 root 3. What are the coordinates of this one? 0 0. What are the coordinates of this one? The average of this one and error. So that if I take this operation and this one, this is for the 3 level samples. For line to line voltage for 3 level, DHA I got only 5.7. So 26% is there. But here, by using this technique, only 5.7% is the DHA with the same number of the samples. You see how drastically it was decreased. For 3 level. In a similar way, if you go for 5 level, this is by including triangle in each sector, I am going to get the 5 level. So these are the samples, rotation of the samples here, all the samples. So that 0 to 360 degrees, this is 5 level inverter, and this is output voltage of the 5 level inverter. You see, it is not good to have a national waveform is increased, so that this GH is 3.6. Just only 3.6% is the GH. Where is 26% and where is 3.6%? That is only conventional. There are not any different algorithms and so that if we see this 3.61 top and all these things will compare to this. 5.7 is 3 level and 3.61 is with 5. So this is the research lab in my department. I have established this research lab with my research projects on this. What are the research projects? Almost 8 PhDs were awarded in this project through this research lab. And we have sponsored research projects. And this is previous level cascaded HPG converter. This is NPC, 7 level converter. And this is with reduced number of switches. I told you we have now with reduced number of switches. This is working with Professor Chandra and University of Pune and also other things I'm doing. Okay. This is about the basics. I think you got a very good idea because majority is already masters in this will be definitely. What are it really? How we are connecting is important in teaching. How we are, if you read any papers, you don't get an idea. Only space vector deflection will be there, should be there. But what is the logic behind it? Like a three-phase induction motor, rotating magnetic field, similarly your inverter is giving same sort of this one, which will be the characteristics of the AC waveform. Okay? Thank you. Any notes, anything else? Any queries or questions?